Okay, so we are on to 2.5. 2.5 deals with the remainder theorem and the factor theorem. So both of these are centered around synthetic division. So we have learned synthetic substitution. Synthetic division is the exact same process with maybe one tiny little detail switch in that process and how you set that up. So first we're just going to start off with the synthetic division. So if I want to divide the function 2x cubed plus x squared minus 8x plus 5 by the function x plus 3. Again, the first thing we check for is any jumps in our exponents. So we have a cubed, a squared, and just x to the first, and then no x at all. So going from 3 to 1 to nothing skips nothing, so we don't need any zero placeholders. Now, let's put all those coefficients up top. So we have 2, 1, -8, and 5. Okay, again, these are coming from all of the different coefficients. So 2, 1, -8, and 5 come from our function up top. We want to set our divisor, or the thing we're dividing by, equal to 0 and solve for x. In this case, that is x equals -3. This number is the one that goes on the outside. That might be the one different thing. Generally, we just told you, here's the number that we want you to do for substitution. Now, you actually have to find what that number is by solving for x. So synthetic division from here on out is going to go the exact same way as usual. You drop that first term down. Okay, so now we have -3 times 2. That's -6. That number comes over here. And then we add. 1 plus -6 is -5. Okay, now we start over again. -3 times -5 is +15. That number goes up here. We add straight down. -8 plus 15. Sorry, I was checking something. -8 plus 15 is +7. Okay, do the process again. 7 times -3, -21. Add straight down, and you will get -16. Okay, so now I want to teach you what these bottom numbers mean. The only number we used to pay attention to was the very last number. Now we pay attention to much more than that. This last number represents your remainder. The second number in is your constant, or just the number. Third term in is your x. Fourth term in is your x squared. So if I went to go rewrite this, it would be 2x squared minus 5x plus 7 plus -16 over what you divided by x plus 3. Okay, so remember two things. We have to tack on this remainder, and it's always written over what we divided by. So again, last term is your remainder. That goes over here. Second in is your constant, just a number. Then your x squared. So this is our actual answer. After dividing this function by x plus 3, this is what we're left with. Okay, so something about synthetic division is the remainder theorem. So what the remainder theorem tells us is a few different things. The first is obviously that when we evaluate this function up here for -3, you get -16. Okay, that's what we used to do. We've been used to subbing this in for synthetic substitution. So evaluating this function for -3 gives us -16. That's one thing the remainder theorem tells us. The other thing it tells us is if we take the number on the outside and the remainder and write it as a coordinate point, that can actually be written as a -3, -16. This is a point on this function's graph. Different ways this can help us when we're trying to graph one of these polynomial functions. If figuring out any kind of point on that graph is huge. And then also, stemming off of that, it can tell us factors or zeros of the equation. So all along, we've been trying to factor functions like this in order to find its solutions. When you do use the remainder theorem, if your remainder is 0, then whatever you divided by, in this case x plus 3, is an actual factor or x-intercept or solution or 0 to that function. Okay, so the next two examples are going to deal with that. I'm going to ask you to prove that the following function is a factor of this function. Okay, I want you to prove that x plus 2 is a factor of f of x equals 3x squared minus 4, oh, that should be 3x cubed. Yes, 3x cubed. 3x cubed minus 4x squared minus 28x minus 16. So again, set up the synthetic division. 3, 2, 1, nothing, so no 0 placeholders. X plus 2 equals 0. Solve for x. We get x equals negative 2. Okay, so put that number here on the outside. All of our coefficients, 3, negative 4, negative 28, negative 16. Go up top. Okay, start this process over again. You drop your first term down. So 3 comes down. Negative 2 times positive 3 is negative 6. Add those up over here. You get negative 10. Negative 2 times negative 10, negative 20, and that goes right here. And now, oh, sorry, positive 20. Two negatives make a positive. So positive 20. Add straight down, negative 8, right? Negative 28 plus 20, negative 8. Negative 2 times negative 8 is positive 16. So we add straight down and we get 0. So the prompt asked us to prove that x plus 2 was a factor of this function. My remainder is 0. The only way you can prove that this is a factor is by getting a remainder of 0. Since my remainder is 0, I can say yes, x plus 2 is a factor. Even more so, I can continue on with this. When we do synthetic division, and this is nothing that you'll need to know for this particular section, but when we move on, you'll need to know this for like 2.6 and 2.7 and 2.8. What you just did was ran this x plus 2 factor through this function. What you got down here is what's left over. Okay, essentially, you've factored out x plus 2. What's left down here is the function left over after factoring out x plus 2. So synthetic division not only helps us do substitution, find points on a graph, find solutions or factors of a function, but it also helps us factor a function out. So this is my remainder, this is my constant, my x, and my x squared. So let's rewrite this out. 3x squared minus x, minus 10x, sorry, minus 8. So this is the function you have left over after factoring out x plus 2. This function and this function are equal. This function right here represents its totally not factored out version, right? It's fully distributed out version. And this has the x plus 2 factor factored out. These are equivalent though. So when you looked at this function to begin with, you probably were thinking, I don't even know how to factor this in order to find solutions. So we ran it through synthetic division and then came over here and we can say, okay, now we're left with this. You could totally put this into quad form in order to find your last two solutions. Okay. So again, the whole method was just find, was this a solution? Yes, it's a solution, but this is the bigger thing that's coming out of it. Okay, one more factoring practice problem. So we want to see if x minus 4 is a factor of this function. Okay, sorry, the light's kind of shining in, so I'm trying to stop it with my hand. So first thing, 3, 2, 1, no x. Okay, so there's no 0 placeholders needed. Set x minus 4 equal to 0, and we get x equals positive 4. Positive 4 goes on the outside. My numbers 1, negative 6, positive 5, positive 12 all come down. Drop that first number down. Okay, so 1 comes straight down. 4 times 1 is 4. Add, we get negative 2. Negative 2 times 4, negative 8. Add those, negative 3. 4 times negative 3, negative 12. Add those straight down and we get 0. So 1, yes, x minus 4 is a factor. Sorry, my pen keeps kind of dying on me. Is a factor. Even more so, let's write this out totally factored out. Okay? So first thing, x minus 4 has been factored out. So what's left over when we're done? This is my remainder, constant x squared. So we have 1 x squared minus 2x minus 3. Okay, I want to challenge you a little bit and push you a little bit further. This was not part of the prompt, right? This is just me pushing you further to help you understand. We have this part fully factored out. Can I factor this more using things that I know? So that would be finding two things that multiply to negative 3 and add to negative 2. Right, x is in front. Let's think. 1 times negative 3 is negative 3. 1 plus negative 3 is negative 2. So we can use negative 3 and positive 1. In order to actually find the solutions, I would set each of these equal to 0. So this is just helping you stem off everything that we've been doing, right? We've been finding solutions. I just want you to recognize that eventually that's what we're doing with synthetic division. Right now, I'm asking you to use it to find factors, to find points on the graph, to use the remainder theorem, to use the factor theorem, but eventually this will be used to help us find all of our solutions as well. Okay, and we could have actually found that it is 4, 3, and negative 1. Okay, that's all I have for this section. So you're just practicing synthetic division to find factors, to find points in the graph, and also pushing yourself to be able to write things out in this factored version. Okay, let me know if you have any